Hello all, welcome to our channel. Today I am going to discuss some important questions from irrigation engineering. All the questions I am going to discuss in this video are already asked in some examinations, and it's also very helpful for candidates also preparing for civil engineering competitive examinations. So let's move on the video.
First question, identify the channel slope with coarser silt based on Lassie's theory. So here three curves are shown in figure and identify the channel slope with coarser silt and based on Lassie's theory. So according to Lassie's theory, the natural silt carrying channels assumes a semi-elliptical cross section. According to Lassie's theory, natural silt carrying channels assumes a semi-elliptical cross section. That means coarser the silt, then the curve is flatter, curve having narrow depth, and for finer the silt, the curve shows a semicircular shape and its depth is greater. So from this figure it is clear that curve 1 shows a flatter curve, that is coarser the silt, and curve 3 shows a semicircular shape with greater depth, so it is finer silt, and curve show is intermediate to curve 1 and 3, that is medium sized silt.
Next question, the safe allowable stress of foundation soil is 4 megapascal and the dam is made up of elementary profile with concrete of relative density of 2.5. Uplift pressure is reduced by 25%. Find maximum height of dam and given gamma W is 10 kilonewton per meter square. In the question, it's given that the safe allowable stress of foundation, that is 4 megapascal, and the safe allowable stress is denoted by small letter f, and that is 4 megapascal, and here the unit is megapascal, so you have to convert it into Newton per meter square. So 4 megapascal is 4 into 10 to the power 6 Newton per meter square. Then next one is unit weight of water, that already given in question, 10 kilonewton per meter square. It's also converted to Newton per meter square. Then it becomes 10 into 10 to the power 3 Newton per meter square. Then dam is made up of elementary profile with concrete of relative density 2.5. Therefore, relative density of concrete is given 2.5 and it is denoted by the letter capital S. One more thing is given in question, that is uplift pressure. Uplift pressure is reduced by 25%. Therefore, uplift pressure coefficient, that is denoted as 75%, that is 0.75, and the letter showing uplift pressure coefficient is C. Therefore, we have to find out is maximum height of dam, and it is denoted by H max, and the equation is F upon gamma W into S minus C plus 1. So all the terms are given here. So just substituting, we get maximum height of dam as 145.45 meter. Next question, irrigation water is to be provided in a field to bring the moisture content from 18% to field capacity 28%. Effective root zone depth is 70 cm, and if the density of soil is 1.3 gram per cc at the existing moisture content, depth of water required for irrigating crop in mm is. So in our question we have to find out the depth of water required for irrigating crop. We have to find out that one. So depth of water required is find out by using the formula. So first of all, we have to find out the value of D by gamma W D. In our question, it is given that into density of soil at the existing moisture content. So gamma W is find out by gamma W equals gamma W by 1 plus W. Gamma W is the density at the existing moisture content, and W is taken as water content. So gamma D is equal to gamma W, that is given as 1.3 gram per cc, divided by 1 plus W. W is water content, that is initial water content, that is 0.18. So on substituting these values, we get gamma D as 1.1016 gram per cc. The rest all are given in our question. Gamma D is, we got the value of gamma D, then gamma W is taken as 1, then D is the depth of effective root zone depth, and FC is the field capacity, then moisture content, available moisture content. So gamma D, that is 1.1016, and gamma W is taken as 1. Then effective root zone depth, that is 70 centimeters. So convert it into mm, then it becomes 700 mm. Then field capacity and moisture, available moisture content is 18%, so it is taken as 0.18, and it is raised to a field capacity of 28%, so field capacity is 28%, that is 0.28, and the available moisture content is given as 18%, that is 0.18. On substituting these values, we get depth of water required as 77 mm. The next question: pick normal stress distribution diagram for a gravity dam. Position of resultant for reservoir empty case, that is E less than B by 6. In the question, we have given that pick normal stress distribution diagram for a gravity dam, and condition is position of resultant for reservoir in empty case. There are mainly two cases, reservoir empty and reservoir full. In reservoir empty case, resultant will move towards the heel side. In reservoir empty case, the resultant will move towards the heel side, and the resultant, that is maximum compressive stress, is on the heel side. And in case of reservoir full, the resultant move towards the toe side, that is maximum compressive stress on toe side. So in the question, condition is reservoir empty, so resultant towards heel side. So in the first figure, resultant is shown in toe, though that's not the correct answer. In the second case, resultant is towards the heel side, and but maximum value is shown at the toe side, but so the second option is also wrong. In the case of third option, resultant move towards heel side, and the same way the maximum value is shown at the heel side. So the correct option is option C. If the question is reservoir full case, then the correct option will be option D. Resultant move towards toe side and the maximum compressive stress on toe side. Explanation for this question is given here. Next question: an unlined canal under regime conditions along with a sill factor of 1 has a width of flow 71.25 meter. Assume the unlined canal as wide channel, corresponding average depth of flow in the canal will be. In the question, it is given that sill factor F is 1 and the width of flow is 71.25 meter. And in case of wide rectangular channel, B is very larger than Y, and the value of R is taken as Y. R is equal to Y. According to Lassie's fundamental equation, for finding out AF square is equal to 140 into 2FR by 5 raised to 5 by 2. Here value of B is 71.25, that's given. Then Y into F is 1, then 140 into 2 into here also F is 1. On solving, we get value of Y as 2.935 meters. Hope all of you understood the questions that are discussed here. This wrap up the section. So thanks for watching. Keep on watching.